Now, from this relationship between volume and pressure, all other things being equal, we can see that pressure is proportional to the reciprocal of volume, or at least it's plausible that pressure. If pressure is proportional to the reciprocal of volume, then less V means more P, and more V would mean less P. You can think about why that's true, and you should stop and think about that and convince yourself that it's so. More T is associated with more P. That follows from the contention that temperature and pressure are proportional. Okay. Similarly, T and V, volume proportional to temperature, P and N, pressure proportional to the number of moles. And from each of these proportionalities, we conclude that PV has to be constant, all other things being equal, again, if N and T are held constant. Okay, P over T constant, if T is proportional with P, and so forth. You should be able to argue for each of these by talking about an intuitive situation, perhaps with a bottle, perhaps with something else. Now, each of these proportionalities, these proportionalities can be empirically observed. They were empirically observed a couple hundred years ago and tested, and we arrived at the variation equation, PV equals nRT. This is also called an equation of state. Okay, R is just a universal constant, or we think it's universal. Of course, we're not completely sure what goes on in the rest of the universe, but indications are that this is probably a universal constant. It's 8.31 joules per mole Kelvin. It's always 8.31 joules per mole Kelvin. It's not variable. So R doesn't figure into variation. It's a proportionality constant that allows us to quantify these relationships. Okay? Now, from this, we can derive that pressure is proportional to 1 over volume if N and T are constant. That's actually fairly straightforward. If N and T are constant, then nRT is constant, so PV is constant, and we have this, which of course implies this. Okay? Another case, if N and P are constant, well, we can rearrange this equation so that N and P are on the same side with R. Remember, R doesn't change. And we get V over T equals NR over P. And since N and P are held constant, that means that V over T has to be constant. V over T constant implies that V is proportional to T, and that verifies what we have. You can do this with any pair of quantities you want to keep constant, okay? And you can get the variation between the other two quantities.